My name is Tasneem. I'm the senior manager at 98 Percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th Percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th Percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into this cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 90th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be placed in that company. I'm confident about that. Thank you.
Hi, I am Karthik Rannan. I am the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it. Thank you.
Good evening, everyone. Bhanupriya, ma'am, you can start the session.
Oh, fine. Thank you.
Yeah.
All right. So today we are going to look at one of the neural network technique called as convolution neural networks. And then we will also do this a small hands-on example of training the model. Okay. So let's just understand first what is convolution neural networks. Just let me share my screen. Just a moment, please. Just a moment, I'm not able to share the screen. No, Chandan, I'm not able to share the screen. Is there any problem? Could you please check once?
Ma'am, I gave access to you. Just try it.
Just,
From
yeah,
my
one second.
side, it's working.
Mm-hmm. Okay, let me check it once again.
If it is not possible, you can rejoin.
Okay, fine.
Yeah. Mom, try it now.
Yeah, yeah, yeah. It's okay now. Thank you.
Yes.
All right. Sorry. So today we are going to discuss about one of the neural networks called as convolution neural networks. So what is this convolution networks? Why we are going to use them is convolution neural networks are used in the image processing and image classification problems. That means if you want a machine to identify an image and see what this image is of, if you want it to classify the given picture into some category, then you can use convolution neural networks. You can train the machine with convolution neural networks by feeding in lots of images. Okay, we have to feed in lots of images of, let's say you want to identify, or if you want the machine to identify the picture of cats or picture of dogs. So you will feed in lots of images of cats and lots of images of dogs, and you will say them data which is called as training data, which will have the image as well as a name associated with the image. So it's something like you're showing pictures to a small kid. So how do you make a small kid understand what is cat or a dog? So you basically show lots of cats and dogs, say this is dog, this is cat, or you show them the pictures and say this is cat, this is dog. So you are trying to train the children based on the pictures or showing them the real cats and dogs. You are labeling them, saying this is the name of that particular animal. So that information is fed into the brain of the child, and next time they see a similar kind of uh, picture, they will identify that as a dog, or similar kind of animal on the street. They will identify them as a dog. So the machine is also going to learn in the same way. Here, we are going to train it on the neural networks. We are going to feed in lots of images. Based on these images, we will also associate certain label along with the images. So this label will help them to identify what is that picture is of. Convolutional neural network processing of the image data. Of course, this can be used for textual data also, but mostly this is used for the image analysis, video analysis. You can extract different frames from the videos. Video is nothing but a series of images put together is called as video, right? So you can extract images from the video and you can do the analysis of the audio and video. So basically, this is used for the unstructured data, right? Making sense? What is convolution neural network? So what are the real life applications of convolution neural network? So you can use convolution neural network for object identification. That means they can detect and locate objects in the given images or videos. It can be used for image segmentation. That means CNNs can segment images. Segment is forming into different groups, okay, into different regions, and tag them with each region, which region this would belong to. Or you can also use CNN to create images. Further, convolution neural networks with generative AI together, you can use them for generating the pictures as well. These days, we have lot of uh, tools, AI tools, which can generate images, right? So all this is based on our convolution neural networks along with some of the Gen AI techniques as well. So AI is a base. In that, AI, like the neural networks, is one part. So neural network use deep learning methodologies to solve the problems like classification, segmentation. All these problems are or business problems can be solved using convolution neural networks. Okay. So basically, this can be used for the unstructured data. You can process images, videos, and you can process text data also. These days, in CNNs, along with the transformers or the recurring neural networks, are also used in processing the text data. So yesterday we have done NLP, right? So that is using some of the pre-built models. So you can also train your models using LSTMs, or you can train your models using CNNs, right? So CNN is an artificial neural network technique. This network, that is CNN network, preserves the spatial texture of the structure of the problem were developed for object recognition, such as handwritten digit recognition. That means if I scan the check, okay, if I scan the check, there will be check amount written in digits, which is handwritten, right? So this handwritten check, when you scan it, it is an image. So we as a human being can read the digits in the image also, but for a machine to read the numbers from an image is not an easy task. It will not be able to understand the numbers inside the image as is, right? So for it, we need to use tools like computer vision and some other natural language processing tools so that the computer understands what is written over there, right? So example that we are going to look at is handwritten digit classification problem. Based on this example, we are going to look at a neural network which will be training on different images that we fed into it. So here, to process the images with the neural network, in how in the world do we feed images into the neural network? Instead of just the numbers, you have to feed in the images here as input as the images. But for a computer, an image is not directly read, right? It cannot understand image as an image. It will understand image as a grid of numbers only. That means it is just rows and columns of pixels. For a computer, an image is just rows and columns of the pixels. Each pixel, what is the number it is carried on, right? That is an image for the computer. So how dark the pixel is decides what is there. So if you see, this is a handwritten image of the digit 8. You can see this is the visualization of the pixels. Wherever you have a dark color pixel, you will have a darker number. So for a computer, though you give the image, it will process that image into a matrix of pixels, that is rows and columns of pixels only. Okay. So implementing convolutional neural network consists of several steps. So the first step is data pre-processing. Okay. Input data has been, whatever the input data that you give will be pre-processed, and it will be, when I say pre-processed, it includes data normalization, it includes data scaling, resizing of the images. All these things will be included in the data pre-processing. Okay. So next it will construct a convolution layers. Convolution layer is nothing but it is going to, I'll show you, yeah, here. Input will be given and it will pass through several layers of the neural networks. So once it passes through several layers of the neural network, the data is pre-processed, and then we will train our model. That is, finally you will have one neural network which will learn from the pre-processed data and try to give you the output like this, whether it is an 8 or not. So the ultimate goal of this particular convolutional network is to identify the given handwritten digit. So if you give the image of the digit, it should be able to find out whether it is 8 or not. I'm just giving you an example. We are building a convolutional neural network to identify only the digit 8. So at the end, the goal of this convolution neural network should be whether the given input is 8 or not. For that, whatever we are discussing, the process of convolution neural network involves different steps. What are these different steps is? So as we understood that the data that we fed into the machine is not directly treated as an image. For us, it will be treated as an image, but for computer, it will not be an image. So it will first split the images. So for a human being, if you look at this picture, as a human being, you intuitively know that pictures have a hierarchy or conceptual structure. That means as soon as you look at this picture, we are able to look at some of the objects and we will be able to identify what is the main subject of this picture. What is the main subject of this picture? If I ask you, you will say there is a boy playing on a horse, bouncing horse in a garden or something. So first, our subject would be the boy, right? Our main priority in the picture is boy. Then you will, maybe your eyes go onto the horse, then maybe in the background grass, and then there's a toy, there's a gate. So this is a hierarchy that we follow, right? As a human being, you will be instantly able to identify what is the hierarchy of the picture. Most importantly, in this picture, we recognize the idea of the child, no matter whatever the surface the child is on. For us, the child sitting on the horse is also child. The child sitting on the grass is also child. Child sitting on something else is also a child for us. But for a computer, child sitting on a bouncy horse might be different because you have trained the model for a child sitting on horse, a child sitting on grass, separate with its separate training data, right? So it might identify all of them as a different objects. So our goal is to make the machine to learn, or our goal is to make it understand that whatever the object that you're looking at in different positions or in different angles, it is the same object. That means if you again go back to your 8 in anywhere in the image, right? If you take the scanned picture of scan image of the check, wherever 8 is written, it should be 8 only. Only if our model is able to identify 8 in the center of the check, but it is not able to identify numbers that are written in the corners, then that is not a good model, right? We need to give our neural network an understanding of translation variance. What is the translation variance here? 8 is 8 no matter wherever it is in the picture. A child is child wherever he is in the picture, right? So this kind of understanding, if you have to give it to your model, we will have to use convolution. So what is convolution? Instead of feeding the entire images into our neural networks as one grid of numbers, right, like one matrix of the numbers, we are going to do something a lot smarter, so that the picture now, whatever we are going to give, is not a complete picture at once, but what we are going to do is we are going to make the picture into smaller segments, or break the picture into smaller pieces called as tiles, so that it our model will have a lot of advantage in identifying an object as an object wherever it is appear in the picture, right? So, and these small segments of the pictures that we are going to make will be overlapping pictures. So if you see the first picture that I have shown you, the boy sitting on the bouncing horse has been split into 77 equal sized tiny images, which are overlapping images. You can see each picture is having overlapping of the other picture. So instead of feeding one single big image, if you feed in this image, each, right, all the 77 images, now the model, the convolution layers in the neural network will try to understand. There is a lot of mathematics involved in processing this data. And finally, it will try to identify the objects in the given picture using those mathematics. So what is the mathematics? Here we will have convolution layers and pooling layers. It is all about numbers only, right? For the machine, all these pictures are just a grid of pixels, 0, 0, 1, 1, like that. So this is a images that have overlapping pixels. So it will take a small filter patch called as kernel. It will do the standardization and normalization of the data. This process is called as standardization or data pre-processing. It will reduce the number of rows and columns. So if you have 1, 2, 3, 1, 2, 3, 4. So 3 rows, 4 columns are there. Applying convolution layer has been reduced to 2 rows and 3 columns. Like this, it will try to convert or try to extract the features of our data point. So if this is a small input tile given to it, the output is only one dimension. This is 2 dimensions, the output is only one dimension. So it will treat and it will extract only the useful information. Where the pixels are darker, only those things are filtered out, like this. Once you give the entire tiles of picture through the convolution layer, and it is converted, each 2-dimensional is converted into 1 dimension. Further, it is going to be reduced using pooling layers. Convolution layer reduces 1 dimension and pooling reduces further more dimensions. So one big tile of images with number of rows and columns might reduce to very small number of rows and columns. So here the point of pre-processing our data is we are reducing the unnecessary pixels are removed. We are only concentrating on those pixels which will be the sharp features of the image to identify what is that image is of. So with this sharp features, and we are saying these features are nothing but 8. So it is going to identify whether a given image is having these features or not. If these features are available, it will say it is 8. Otherwise, it will say it is not 8. So that's the idea about training the model. So this is the full length network. Once the image is given, it will be split into smaller pieces called as convolution, wherein they are converted into the smaller pixel size. Again, pooling layer will be applied. Pooling layer further reduces your pixels so that only the most important pixels are standing out. And then this max pooling, whatever the output that we are getting, this is given to the fully connected neural networks. This is going to identify the features of the max pool data and then try to identify 8 as 8 or not. So here this fully connected networks is going to get trained on the features that we have extracted from convolution and pooling layers. So this model gets trained on the features and the label. So these features and the label. So we give both X and both Y. So when we are treating the input image, we will also give Y also. X means the input, Y is output. So this, whenever I'm giving the model has to get trained, right? So model training happens on both the input data and the label also. So we will have two things, features and labels. So that means features are nothing but the images here. Without pre-processing, we give it, but our CNN model is having an inbuilt mechanism to extract the features. Are used for feature extraction. So once this feature extraction happens, along with these features, you will feed in the labels also to the fully connected layers, that is neural networks, artificial neural networks. So this layers will understand, okay, for this feature, the label is boy. Maybe if you have another picture of the girl, it will have a different feature extraction and the label will be girl. So it will learn what features are making boy, what features are making girl. That training will be done here and the model will be ready. And this model, if you give another picture, the test picture is there of girl or boy, you give the test picture. So this will give you the output of this text picture as girl or boy. It will be able to identify whether it is girl or boy. So if you are trying to make a model to identify girl as girl, boy as boy in a given picture, so this is how it happens. So let's just look at one example. I'll show you the model. It's not simple, but I'll just show you how it works as well. The coding part is really difficult, but you can look at it, no problem. Okay. So this convolution neural network we are going to do on the tensor flows, and this is developed by the Google itself. So this is given by Google. This Colab that I'm showing you, notebook, this is also from TensorFlow only. The official website is having this Google Colab notebook. I'll just put the link in the chat window. If anyone is interested, you can go through this and along with me, you can practice also. So this is a license. It requires licensed version of Apache license. So we just need to have the proper Gmail ID to use this. Okay. So you can run in Google Colab or you can use the source code on the GitHub, or you can download it and use it in your Jupyter notebook also. But I am using it in the Google Colab itself because we will have our cloud resources running here. If you have to run this kind of training on your machine, it will take a lot of time because I'm going to use 60,000 training images here. It will be a bit, it would require a lot of CPU, GPUs. So we are going to connect to the Google provided T4 server, hosted runtime server. So RAM and disk, all these things, whatever is allocated to us is very high. So you can see backend GPU is running in this, and the RAM is 12.67 GB, disk is assigned as so much. So this is a very powerful server that is running here. So we can use of this instead of running it in our local machine, so that you will have more fast performance. The training of the model will be very fast. So this convolution neural networks that we are going to build are from Python libraries called as Keras and TensorFlow. Both TensorFlow is developed by the Google. This is a library in Python, okay, developed by Google. So this TensorFlow will help us to build a sophisticated neural network. So import TensorFlow as TF. So whenever you want to use some modules, we have to import those modules and use them. From TensorFlow.keras, import datasets, layers, and models. And this matplot library is a visualization tool. If you want to visualize what is happening, you can use matplot library. So there are some pre-built datasets that are provided as part of the TensorFlow. So I'm also importing that TensorFlow datasets. So the dataset that we are going to work on is having 60,000 color images in 10 classes. This dataset is called as Cipher 10 dataset. So total 60,000 colored images are there with 6,000 images in each class. So 10 classes here means like each label. So dog, cat, car. So each of the images, dog images, there are 6,000 images of the dogs, 6,000 images of the cats. And if you want to see what are the different categories that we have in this data set, we can see those things also. Let's just first download the data set and split that into train and test. So in every model, whenever we are building a deep learning model or a machine learning model, whatever the data set that is given to us, we will be dividing the data into training and testing. We will build the model on the training data set and test it, because how it is performing you have to know, right? So we will keep some data without touching it or without showing it to the model. We will keep it separately and we call it as test data or validation data. So we have to split the data into train and test first. For that, I am using here 50,000 training images, 10,000 testing images. So if you once you run this line, training images, training labels, test images, test labels, load the data set. So this is load the data set and give you the output. So it has loaded all the data set. So now you can verify what are the different classes that we have. In this data set, we have classes airplane, automobile, bird, cat, deer, dog, frog, horse, ship, and truck. These are the different names of the classes or the pictures of the data having pictures of these 10 things. So just to show you, this is plt.figure. I'm using a for loop to show you 5 by 5, 25 pictures are shown. You can see frog, truck, deer, automobile, bird, horse, ship, cat, deer, horse. So this might be pixelated images for us, but our model will be able to identify the pixel sizes and pixel numbers from this blurred images also. For us, it is really necessary to have the clear pictures to understand, but model will be able to understand from this clarity of pictures as well. Right? I'm just showing you first 25 pictures. Okay. So these are the pictures. So like this, we have 60,000 images. In that, we have taken 50,000 for the training of the model. That means we will give 50,000 images to the model to understand. So this is frog. So it will read this, try to process it as the features and label as frog. This is truck. The feature extraction will happen and say as truck. See, you have different pictures of trucks. We have different pictures of dogs. We have different pictures of automobile. We have different pictures of the deers. That means we are making our model to understand from different examples. Horse, this could be horse, this could be horse, right? Trucks, how many types of trucks are there? This is one truck, this is one truck, this is another truck. Like this, we have 6,000 images of each class given. So when you are splitting it into 50,000 and 10,000, maybe lesser 5,000 images of each class are taken into the training data, and 1,000 we are keeping it for testing, right? So now we are going to build our convolution neural network. So we are adding convolution layer, pooling layers. So like this, you can add n number of layers. So we are adding 3 sets of convolution and pooling layers. Right. If you look at this, this is the architecture of our model. You will have convolution, then pooling, convolution, pooling, then convolution. So one convolution has to be backed up with one pooling layer. Convolution has to be backed up with one pooling layer. After all the convolution and pooling layers are done, we will have the one flattening layer, that is dense layer, the fully connected layer, which is actually taking the data and training. So define that as well. After that, look at the model summary. So now we have just defined the architecture, how many layers should be there, convolution, pooling, convolution and flattening and dense layer. So this is the architecture, but we did not feed in our data yet. So in the next step, we are compiling and training the model. So model.compile here is, these are certain parameters that we have to define. Okay. After defining certain parameters, you will fit in the data into the model. Model.fit training images and training labels. If you see, we have to give the features as well as a label also. Once it builds the model, it has to test it also, right? So for testing, I'm giving the test images and test labels. So it is going to run the model. So this model is going to be a very, what we can say, is a very extensive and completely complex model, because it is having 10 classes and each of them having 5,000 images. So total 50,000 images have to be trained. Okay. So you can see it is going to get trained in different batches. So after building the model, so once we build the model, once you run this, it has just built the model. So if you want to evaluate the model, let me just run this. I've already shared the link for the code file, Praveen. I think you might have joined late. Model of somebody. No, that is not HTML format, Praveen. That is Google Colab. You have to open it in the Google Colab. It's an IPNV file only. If you want, I can share it once again. Don't worry. I will share it at the end of the class. Now let me run this. It's just running. Training is happening. So and see, if you see this, there are two accuracies that it is showing. One is uh, training accuracy, the other one is testing accuracy. So whenever you look at your training accuracy, it will keep on increasing with the number of iterations that we do, but testing accuracy will increase for a certain point, then it will decrease. So this number of iterations are enough to get the maximum accuracy. So if you want to see what is the test accuracy on the whole, so it is giving you 72% accuracy. So how it is happening is, if you see here, we are able to get the model, this model, whatever we have compiled, and we have stored it in history. So this model, history.history, accuracy is taken, history.history, validation accuracy is taken. We are just plotting this on the x-axis and y-axis. Right? And then test accuracies can be calculated here. Model.evaluate, the model that we have built dot evaluate, we are giving the test images to it and test labels. So once we give the test images to it, it will try to predict what is the label of the image. That means it will try to tell whether it is dog or cat, and then compare that labels, whatever is produced by the model is compared with the test labels. Okay, it is compared with the test labels, that is actual labels are there. So truck image is given, the truck label is there, right? So the actual label and the predicted label from the model, both will be compared, and if they are matching or not matching is evaluated, and that is given to us as test accuracy and test loss. Test accuracy is how many labels are matched. Out of 10,000 pictures given to the model, how many were able to be correctly predicted? That means, well, correctly predicted means dog is predicted as dog, cat is predicted as dog. That means it is matching with the actual labels of your test data. So if you take any of the test data, you will have to get some prediction. What is the prediction here? It will just give you the label, which category that image should belong to, whether it will belong to any one of the classes. How many classes we have? 10 classes. Airplane, automobile, bird, cat, deer, dog, frog. So it is about any one of the image that you can give and see what is the label that it is giving. So output will not be the image here. Output will be just the label. So if I give the frog image, it has to tell me there is a frog in it. If I give a bird image, it has to tell there is a bird in it. Horse image, there is a horse. So like that, I'm giving all the test images here. If you go to the last step, we are giving all the test images to the model. So what does this test model will do? It will try to predict which category that image would belong to, and that category is compared to the original category, and if they are matching, that's an accurate. If all the pictures have correct predictions or predicted labels, that means it's correct 100% match with the original data, so you will have 100% accuracy. But here the accuracy is 72%, means out of 10,000 test images that we have given, only it is able to correctly predict 72%, that is 72,000 or 7,200 images were correctly predicted. Making sense? Yeah, yes, no, maybe can I have you some of your questions? If you have any questions, you can ask. No questions? So I'll share this file with all of you. Just check if you are able to open this. So Praveen, you said you are not able to open. I will go to. Yes, I will share 1 second. This is today's file, whatever I've shared right now. So if you want to look at yesterday's file, sentiment, this is a file that I've shared yesterday, right? Named entity recognitions. This is a file that I've shared yesterday. Yeah. Okay. Let me just share here. Yeah, anyone with the link can access it. So I'll just copy the link. This is the file that I have shared yesterday. So you can see if you're able to open it or not. So this is how we train the models basically. For training the models, we need to have the training data first. So you can apply it to any of the business problems. The only thing that we need to have is we need to have the training data. So the training data is very, very important for a model to get trained. There are so many pre-built models are also available, but it will not be very customized approach if you want to use the pre-built models. Okay. So yesterday we have seen language models, which are very much pre-built models. So there are many object identification pre-built models are also available. So there is something called as YOLO. Have you heard about YOLO? Pre-built models. Object identification in Python. So there are PyTorch object detection with pre-trained networks. You can use PyTorch. You can use lot of pre-built methods. Let me show you the object detection. TensorFlow Lite is also there. So this is object detection method. So it will identify the objects in the given picture. So apple is recognized as apple. What is a percentage? Banana is recognized as banana. What is the percentage? So you have pre-built methods. You just need to download the starter model. It will have already the trained model. That means it is trained on different fruit pictures. So if you give a picture, it will be able to identify what are the different images. I mean, what are the different objects that we have inside this image. So this you can deploy it directly using Android or iOS. So directly you can integrate with your applications as well. So for image classification also we have. See, it identifies this entire thing as banana. So object identification and image identification, the only difference is objects means you can have several objects in the image. So it will identify each object and give you the object name in the image. But when it comes to image, on the whole, what is this image or which category this image would belong to will be identified. So that's the difference between image identification or image classification and object identification. So what is a model is of how you can download it, how you can customize it according. The pre-trained models provided are trained to recognize 1,000 classes of images. Okay. For a full list of classes, see the labels file in the model.zip. You can download the model and you can use them. Right. So this is a model that we have. So you can download them and integrate it with our applications. So data image classifications with CNN. So here it is completely the data that we have seen is this data set. So how it is done is clearly given. So you can also use pre-built models or you can train your own models. All right. So hope with this workshop you have got a little idea about what is artificial intelligence, what is machine learning, what is NLP, and some basic understanding of Python, how to execute the Python files, and how to use Google Colab, deep learning, convolution neural networks, what are pre-built models, what are trained models. Hope you have certain idea. Can I have your experiences? Can you give me in the chat window? Can you write something about this workshop? What is that you have understood? What is that you have taking away from this workshop? Yeah, no one has anything to say. Any questions or any queries that you might have on AI? If you want to pursue AI further, how do you want to go about it? No questions from your side? All right. So if you have no questions, thank you so much. It was nice interacting with all of you and engaging with all of you guys. Thank you so much. Chandana, I am done. Thank you, Vaishnavi. Yeah, thank you for your feedback. I'm glad that you had certain gain from these sessions. Okay, thank you, Vasanta Sai. You gained some knowledge. Very good. The gist of this workshop is that you would require some machine learning knowledge, certain mathematical knowledge and statistical knowledge. Python programming is very important to become an AI professional, right? ML, AI, deep learning, NLP, and Python. These are the 5 things that are required if you want to become an AI professional, right? Yeah. So I have given you introduction to all these things in last 5 days. So this is an idea. If you want to take it forward and learn the full-fledged course, you now have the roadmap. What is that you have to learn, right? Thank you so much, guys. All right. Thank you. All the best, everyone.
Yeah, thank you, madam. So, students, you can continue with your recording sessions, okay, which are we provided. Yeah, that's all from my side. Thank you.